Hello students. Today we'll see Standard 8 Science Lesson number 7 Metals and Non-Metals. So all pay attention in your textbook also. What are the three types in which the elements are generally classified? So students, we know that elements are generally classified as metals, non-metals and metalloids. What are the metals and non-metals that we use in everyday life? Metals we use in everyday life are copper, silver, iron, gold. Also, we are using aluminium, iron, steel, stainless steel, and non-metals we are using carbon, phosphorus. But in our day-to-day life, we are using chlorine, iodine, oxygen. So these are the non-metals. All the objects or materials in the world are made from elements, compounds, or their mixtures. Scientists classified all the elements in three general types, which are metals, non-metals, and metalloids. Let's see one by one. First, we'll see about the metals. Gold, silver, iron, copper, aluminium, magnesium, calcium, sodium, platinum are a few metals. These metals we know all. Metals have luster. Luster means metal shines. Metals are hard. Wire or sheet can be from them made metal. Metals are good conductors of heat and electricity. Metals lose their valence electrons to produce positively charged ions, that is, cations. Now let's see physical properties of metals. Physical state. Under ordinary temperature, metals stay in solid state. However, metals like mercury and gallium are exception, which are in liquid state even at room temperature. You might have seen a doctor's pressure gauge to measure blood pressure during your visit to a dispensary, accompanying your relative. In that, you might have seen a grey colored liquid in a glass tube. What is that metal? The metal is nothing but mercury. Now, let's see the second property, that is luster. Take copper vessels at your home, scrub them with lemon and rinse with water. Observe the luster before and after cleaning. Light gets reflected from the clean or freshly cut surface of metal and the metal looks lustrous. You might have experienced this. So this is a luster property. Now let's see the next property, hardness. Generally, metals are hard, not soft. Exception, sodium and potassium are soft and can be easily cut by a knife. So this is the third property of metal. Now let's see the next property, ductility. Have you ever gone to a goldsmith shop? Have you seen the goldsmith making a wire of gold or silver? Yes. So, when a metal is pulled through a hole, its wire is formed. So, this property of metal is called ductility. Now, let's see the next property, malleability. For that, take an iron nail, place it on a platform and keep on hammering it. After some time, you will see a thin sheet forming. This property is called malleability of metals. So this is the sheet of metals. Next property is conduction of heat. Take a copper plate, fix some wax at one of its ends. Heat the other end and observe what happens. You can see that heat is travel from one point to the another point. This is called a conduction of heat. Metals are good conductors of heat. Silver, copper and aluminium are the best conductors of heat. Now let's see the next property, conduction of electricity. Metals are good conductors of electricity. Lead is an exception, which is neither a good conductor of heat nor a good conductor of electricity. So this is the property of conduction of electricity. Density. Metals have high density. Sodium, potassium, lithium are exceptions because they are having lower density than water. The density of lithium is only 0.53 gram per C. Next property is melting point. The temperature at which a solid changes into a liquid, that is called a melting point. Generally, metals have high melting point and a boiling point. Next property, we'll see sonority. Sonarity means the ability of metals to produce a particular sound when it is tapped on a hard surface is termed sonority. What is the metal that your school bell is made of? Your school bell is made up of brass. So metals are sonorous. They produce sound on striking. Now, these are all the properties of metals. So let's revise the properties. First is its physical state, luster, hardness, ductility, malleability, conduction of heat, conduction of electricity, density, melting point and boiling point, and last is sonority. So these all properties of metals we have seen. Now let's see about the non-metals. Carbon, sulfur, phosphorus are few non-metals. Generally, non-metals are brittle and non-lustrous. Now let's see physical properties of non-metals. Physical state. At ordinary temperature, non-metals occur at solids, liquids and gaseous. For example, solids, carbon, sulfur and phosphorus. Liquid, bromine, and gases, hydrogen, nitrogen and oxygen. Now, luster. The second property is luster. Non-metals do not have luster. That means non-metals do not shine. But some exceptions are there, like diamond and iodine crystals. Some nonmetals are colorless while others have different colors. What is the color of carbon in the form of coal? It is black in color. Sulfur is yellow in color. Just now we have seen sulfur. Here in the picture you can see sulfur is yellow in color and bromine is brown in color. So this is the property about the luster. Now let's see next property, that is Brittleness. Take coal and hammer it. See what happened to it? Solid nonmetals are brittle because coal can easily convert into powder by hammering. So this is called a brittleness. Some nonmetals are soft. Diamond is an exception. Why? Because diamond is the hardest natural substance. So this is an exception. Now let's see the next property, ductility and malleability. Non-metals are neither ductile nor malleable. That means, students, we cannot make wire or sheet from any non-metal. So, non-metals are neither ductile nor malleable. Now let's see next property, conduction of heat and electricity. Non-metals are bad conductors of heat and electricity. That means heat and electricity cannot pass through the non-metal. But there is one exception, that is a graphite, which is a very good conductor of electricity. Now next property, that is density. Non-metals have low density. For example, if you can observe coal, and if you put it in the water, you can see that coal will float on the water. That is what its density is lower. Now, melting and boiling point. Non-metals have low melting and boiling points. Exception, the solid non-metals, that is carbon and boron, melts at high temperature. Always remember that gold, silver, aluminium are highly malleable metals. A sheet of thickness 1 by 10,000 millimeter and a wire with a diameter 1 upon 5,000 millimeter can be made from gold. Now let's see next, metalloids. Some elements such as arsenic, silicon, germanium, antimony have properties which are intermediate between metals and non-metals. So such elements are called metalloids. Now let's see chemical properties of metals. So in that, first we'll see electronic configuration. Electronic configuration is the basis of chemical behavior of elements. Majority of metals have up to 3 electrons in their outermost shell. Let's see a table to get an idea about this. So the metals, first sodium, atomic number 11, and its electronic configuration is 2, 8 and 1. Magnesium, atomic number is 12, electronic configuration 2, 8, 2. Aluminium, atomic number 13, its electronic configuration is 2, 8, 3. Formation of ions. Metals have a tendency to lose their valence electrons to form positively charged ions, that is, cations. So with the formula or with the equation, we can understand it better. So first is given Na having electronic configuration 281. That means outermost shell contains only 1 electrons. So sodium atom shares the 1 electron. So gives away Na. If it gives the electron, that means it carries positive charge. So it carries Na plus, that is positive charge. And now the electrons are 2, 8. And the 1 electron is giving, so it is 1 plus 1 electron. So this is the formation of sodium ion. For magnesium, electronic configuration is 282. That means it contains 2 electrons in its outermost orbit. So it is easy to give 2 electrons for magnesium. So after giving 2 electrons, it will be, or sharing 2 electrons, magnesium carries 2 positive charges. So Mg++ plus 2 electron, it is called the magnesium ion. Third is aluminium, 283. So it contains 3 electrons in its outermost orbit. While our ion formation, it gives 3 electrons, so it carries positive charge. So Al+++ and plus 3 electrons. This is nothing but aluminium ion. So this is called the ion formation. Now next property of metal is reaction with the oxygen. Now when metal combines with oxygen to form their oxides, so equation is metal plus oxygen gives out metal oxide. The metal oxides are basic in nature. Metal oxides reacts with an acid to form salts and water. So metal oxide plus acid gives out salt plus water. Next point is reaction with acid. Take dilute hydrochloric acid in a test tube. Then add zinc dust to it. Take a glowing splinter near the mouth of the tube. Observe the glowing splinter. You will notice some sound coming out from it. Most of the metals reacts with dilute acid to form metal salts, while hydrogen gas is released. And the equation of this reaction is metal plus dilute acid gives out salt plus hydrogen gas. Now let's see the reaction with water. Most metals do not show any observable and fast reaction with cold water. So metal does not give any reaction with the cold water. But some metals like sodium and potassium react with cold water to produce their hydroxide and hydrogen gas. Magnesium metal requires steam to give similar reaction. Now let's see chemical properties of nonmetals. So first we'll see electronic configuration. Most of the nonmetals have 4 to 7 electrons in their valence shells. Let us see nonmetals. Nitrogen atomic number is 7. So the electronic configuration will be 2, 5. Oxygen atomic number 8. So the electronic configuration will be 2, 6. Chlorine atomic number 17. Electronic configuration will be 2, 8, 7. So this is the electronic configuration of different nonmetals. Now let's see the formation of ion with the help of the equations. Nonmetals have a tendency to accept electrons in their valence shell. We have studied about the metals, that is metals have a tendency to lose their valence electrons. So metals always lose their valence electrons while nonmetals always accept electrons in their valence shell and they carry negatively charged ions, that is called anions. Let's see. Chlorine. Chlorine always accept the electron. So the equation will be Cl plus E gives out Cl288. Cl minus 1 electron it is accepting. So it carries a negative charge. So it will be Cl minus. And the last orbit now it contains 2, 8 and 8. 8 electrons. Octet state is completed. So this is the ion formation of chlorine. So this is chloride ion. Now for oxygen, electronic configuration we have seen it is 2, 6. So 2 electrons are less to complete the outermost orbit. See, in the outermost orbit always 8 electrons should be there. So 6 are there for oxygen, 2 are less to complete the orbit. So oxygen accept 2 electrons. So accepting means it carries the negative charge. So O plus 2 electrons gives out O negative negative, that is carries the 2 negative charge. So and the outermost orbit will contain 2 and that is 8 electrons. So the outermost orbit will be completed and the ion is formed, that is oxide ion. Same for nitrogen gas. Nitrogen electronic configuration is 2, 5. So 3 electrons are less to complete the octet state. So nitrogen accepts 3 electrons and carries the 3 negative charge. So it and the ion is formed which is called nitride ion. Now let's see the reaction with oxygen. Non-metals combine with oxygen to form their oxides. So the equation will be non-metals plus oxygen gives out non-metal oxide. The oxides of non-metals are acidic in nature. They react with bases to form soluble salt and water. For example, carbon plus O2 gives out CO2. CO2 plus 2NaOH gives out Na2CO3 plus H2O. The oxides of nonmetals react with water to form an acid. Let's see which acids are formed. CO2 plus water, that is H2O, gives out H2CO3. That is called carbonic acid. SO2 sulfur dioxide plus H2O gives out H2SO3, that is sulfurous acid. SO3 plus H2O gives out H2SO4, that is sulfuric acid. So these are the acid formed by the nonmetals. Nonmetals do not react with dilute acid. Now let's see the uses of metals and non-metals. Here is a chart given, name the metal. So students, here you can write any name of the metal. I have written gold and copper. You can write silver. Any metal you can write silver, platinum, which we have seen just now. And in everyday life where we are using that also you can write. So this is the example I have given here. You can change the metals and non-metals and accordingly you will write their uses. Now let's see the next topic is a noble metals. Some metals like gold, silver, platinum, palladium and also rhodium are noble metals. They occur in nature in the elemental state. Gold, which is 100% pure, is called 24 karat gold. Pure gold is soft. As a result, the ornaments made from pure gold bend or break due to pressure. Therefore, goldsmiths mix it with certain proportion of copper or silver. Ornaments are made from 22 karat gold or gold with still smaller carat value. So this is about the noble metals and about the 24 karat gold. Now let's see the uses of noble metals. Gold, silver, and platinum are used to prepare ornaments. Silver used in medicines. It has antibacterial property. Gold and silver also used to make medals. Gold and silver also used to make few electronic devices. Platinum, palladium metals are used as a catalyst. Now purity of gold. When we ask a rate of gold in gold shop, it always differ. Why is it differ? Because the cost or the rate of the gold is always depend upon the purity of gold. Gold is a noble metal. In nature, it occurs in element form. 100% pure gold is 24 karat. Pure gold is soft. Therefore, gold ornaments prepared by pure gold may break or bend due to pressure. Hence, goldsmith add specific amount of copper or silver in pure gold. Now let's see about the percentage in the gold. That is 24 karat gold contains 100% gold. 22 karat gold has 91.66% gold, and same way so on given. 18 karat contains 75%, 14 karat contains 58.33%, 12 karat contains 50%, 10 karat contains 41.66%. So this is the purity of gold. Now corrosion. Gases in the air reacts with metals in presence of moisture to form metal compounds. The metals get affected by this process and undergo what is called a corrosion. So in day-to-day life you must have observed this type of the corrosion on the iron. So this is nothing but the metal react with the gases, and that is called the corrosion. There is a Statue of Liberty in a sea near New York City in America. The original surface of their statues was made of copper, but now it looks green. This is because green colored copper carbonate has been formed by a reaction of copper with the carbon dioxide and moisture in the air. This is an example of corrosion. A reddish colored deposit is formed on iron by reaction with the oxygen gas. Greenish colored deposit is formed copper by reaction with carbon dioxide gas. A blackish colored deposit is formed on silver by reaction with the hydrogen sulfide gas. So these are the examples of corrosion, and that we are observing in our day-to-day life. To prevent corrosion of metals, layers of oil, grease, varnish, paints are applied on them. Also, painting with another non-corroding metal is done. Iron is arrested by zinc plating. Due to these processes, the contact of metal surface with the air is lost and corrosion cannot occur as the chemical reaction cannot occur. So this is all about the corrosion. Now let's see next topic, alloy. Alloy means a homogeneous mixture. Homogeneous mixture of two or more metals or homogeneous mixture metal with non-metals is called alloy. Alloys are made by mixing a constituent elements in as per the requirement. For example, stainless steel. Stainless steel is a alloy. Is used at home are made up of an alloy of iron with carbon, chromium and nickel. So these are the materials. With this, the alloy of that is the stainless steel is made up of. The alloy bronze is formed from copper and tin. So this is a bronze. It is made up of from copper and tin. There is an iron pillar in the premises of Qutub Minar in Delhi, made about 1500 years ago. The pillar is lustrous even after so many years. This is because our ancestors had made it from an alloy. It contains small proportion of carbon, silicon and phosphorus mixed in iron. Now, a cheap variety of stainless steel is made sometimes by using copper instead of costly nickel. You might have seen the vertical cracks in stainless steel vessels. So, if the stainless steel is cheap, we can see a crack in the vessel. So, this is all about the lesson metals and non-metals. Thank you, students.